Hey everybody, today I'm going to talk about integrals and absolute value. So in the previous video in this little mini series I talked about derivatives with absolute value, and in that video before that I talked about absolute value in general, kind of applied to metric spaces and metrics and topology, stuff like that. So if you're interested in those things, definitely check those videos out, but you don't really need them for this video. This is kind of just a one-off video. All you need is just knowledge of integrals, so yeah. Okay, so here I have a function f of x, and you can see it goes from a to b. This b, I kind of just put it down there. So you start off positive, then you go negative, and then positive again, right? So I have two things that I want to consider. The first is the absolute value of the integral from a to b, and the second is the integral from a to b of the absolute value of our function, right? And I want to compare these. So first, if I want to compare them intuitively, I want to give these things numbers. So let's say the area of this segment here is like, I don't know, 2, right? And then the area of this segment, it's going to be, I don't know, it looks like about 6 or something, so I'll just call it 6. Actually, it looks like a phi. Let me just give it a better 6, there we go. So this is going to be negative, but since I drew it under the x-axis, it's assumed that it's negative, so it's a negative 6 technically. And then up here, I'm going to say this is probably about 5, right? So if we actually integrated this, just the function itself, it would just be 2 minus 6 plus 5, okay? So it's going to be 7 minus 6, which is 1. So our area of f of x is 1. Okay, so that's pretty much all we needed to do, and we take the absolute value of that. So let's actually do that. So this is going to be the absolute value of 2 minus 6 plus 5. And I'm writing it out to show you the process because it's really easy to see what it is. And this we said was just 1. The absolute value of 1, so I'll just put, let me make it so it doesn't look like 3 ones. So the absolute value of 1, which is just 1. Alright, so this is absolute value of 1. So here, now we're considering, what if we took the absolute value of our function first and then integrated it? So first we need to actually see that. So let's draw. So our function would look pretty much the same for this first and third intervals here. It's just that this second interval would look different because since we're taking the absolute value of it, we're going to flip it over the x-axis because it has to be entirely positive. So let me draw a dotted line to show you kind of what that would look like. So let's see, it would look something like this. Something like that. Let me draw it a little better. Okay, whatever, it's good enough. So I just drew a dotted line to show you kind of how it would look like. It would be the same area, but it would be positive instead of negative. So the way we would do it, so let me actually label this as the absolute value of f of x. Okay, so the way we would do this is we would, hold on, there we go, we would basically just take each portion, right? Because this is also 6, but it's positive, right? So we're just going to say, well, it's the absolute value of 2 plus the absolute value of negative 6 plus the absolute value of 5. So again, since these areas are already positive, it doesn't matter. The absolute value is not going to change anything. But it will change this negative area. It's going to make it positive. So we just have 2 plus 6, right? Because this is 6. So 2 plus 6 plus 5. So 11 plus 2, which is 13. So yeah, basically that's that. So you can see that this guy will be bigger than this guy. And this is actually pretty much always true. The only case where this isn't true is when they're equal to each other. And that occurs whenever your function, so let me just draw another example of a function, whenever it's entirely positive over that interval. Okay? If it's entirely positive, the absolute value of the function is exactly the same as the function itself. So it's not going to change anything. Okay? So in other words, the integral from a to b of the absolute value of f of x is going to be greater than or equal to this guy. And this occurs in pretty much every single case. Now I'm not going to prove that to you, but I do have a good video. You can watch QN Cube's video, so that's his YouTube channel. He made a really good video proving this, and it uses a little bit of complex analysis and all that, but I think it's a really interesting video regardless. So I would definitely encourage you to watch that. A couple other things I want to note is, well, if we're taking the integral of the absolute value, we express it this way, right? So here it's kind of boring because it's like, oh, just take the integral of, like we know how to take this integral and then take the absolute value of it. It doesn't really make a difference. But this guy's a little more interesting because we can't, like, if you gave me something like this, where you actually gave me a function, so like, I don't know, the integral of the absolute value of sine of x, right? That's really hard because you can't really do much. You can't really do a u substitution or anything. So what you would have to do is break it up like this. So we can kind of generalize this. So let me put it over here. So the integral, and I'm not going to say a to b. I'm going to say from, I don't know, I'll just call it c. So c1 to cn, okay? Now, each of these points c happen whenever f of x is equal to 0, okay? So this would be c1, c2, c3, and c4. So in this case, we would have 4. Here we wouldn't have any, but I guess it would just be the bounds. So this also includes the bounds. So the bounds and also where the function equals 0. So that's kind of the description, right? So the integral of these guys, of the absolute value of f of x dx. So let's think about this. Well, we're going to be summing up the absolute values of these individual areas of each of these pieces, right? So we're going to take the sum, and I'm not concerned about the bounds yet. We're going to cover that in a second. But then we're going to be taking the absolute values of each of the integrals. So of the absolute value of the integral from ci, so just one of these c's, all the way to ci plus 1. Okay, so let me make this a little bigger. So we're choosing one of these c's, right, and we're going to be summing over all of them, so it's okay. So we take one of these c's and we take it to the next one. So what that means here, for example, c3 to c4, that's what it means. c3 to c3 plus 1, which is 4. So c3 to c4, okay? That's what that means. And then, so we're going to be integrating this, but our function here. Now, notice how there's no more absolute value in here. And that's because, again, we're taking the area. So here, this area, like this -6, comes from this function down here. But then we're taking the absolute value of it. So we're taking the area from the function, and then we're taking the absolute value of it. And then we're summing all of them from here. So we're summing each portion. So now let's figure out the bounds of the sum. Well, the sum, it should start at 1, right? So I equals 1. And we should put n, right? So if we have an n here, we do run into an issue. Because what if, at this last endpoint, we're going to have an n plus 1. And we don't know what n plus 1 is. We just go up to n, right? So we have to take n minus 1. Oops, let me make that 1 a little better. Oops. So we're going to be doing n minus 1. Okay. So that way, we have this cn minus 1 to cn at the very end. Okay. So this is another really interesting thing, like derivation from what we've observed. I don't really know of a proof of this. If you guys find one on YouTube or online, then I really encourage you guys to link it below. One last thing I want to talk about is the integral of velocity versus the integral of the absolute value of velocity. Right? So this guy gives you the displacement of any, let's say we're talking about one-dimensional motion, and let's say we have a particle that travels on one dimension, and it starts here, and then it travels over here, and it ends up here, right? And then it goes back this way, and then ends up here, and then let's say it goes way over here, and then kind of comes back, right? And let's say it goes past our endpoint. So this is where we started, and this is where we ended. So our displacement is going to be this little tiny bit. So it's going to be a negative amount, since we by convention, right is positive and left is negative. So we went left of where we started, so it's going to be negative. But this guy, remember, each of these movements, so this movement from here to, I think we went to here all the way, from here to here, this, when we're taking this guy, it's going to be negative. But since we're taking the absolute value of it, it's going to be positive. So we're going to add each of these movements up. So you can tell that, no matter which way we go, we're going to keep adding it. We're going to take the absolute value of it and add it to our sum. So this is going to be a huge number. So this guy gives you displacement, while this guy gives you the total distance traveled, because you're splitting it up into all of these little pieces and then summing up all of them when they're positive, the modulus, the absolute value of it. So that's a cool little application to physics, But yeah, this is in general integrals and absolute value. So this is pretty much the last video I'm going to do in this little mini-series. I hope you enjoyed. So yeah, thank you guys for watching, and I'll see you in the next video. Bye guys.